Hello everyone. So let's start with question number 51. The question number 51 says that match list 1 with list 2. Okay, so it is a match type question, match the following type question it is. And in list 1 we have been given the conversion. Okay, and in list 2 we have to match the number of Faradays that is required. Okay, so for A, 1 mole of H2O to O2. Okay, we have to convert 1 mole of H2O to O2 and we have to find out that how much Faraday is required for this conversion. Also in second one, 1 mole of MnO4 minus to Mn plus 2. It is also required to calculate the number of Faradays. In C, it is given 1.5 mole of Ca from molten CaCl2. Okay, and from D, 1 mole of FeO to Fe2O3. Okay, so like this, we have to calculate the number of Faraday. So which topic it is? It is from electrochemistry, right? It is from electrochemistry and it is the subtopic says that it is from Faraday's law. Correct? So let us try to calculate the Faraday's law. From Faraday's law, first one, what is there? 1 mole of H2O to O2. So H2O needs to be converted to O2 plus H plus. Okay, it is 2H plus 2 electron. Like this, right? So how much mole of H2O is there? 1 mole of H2O is there, and from 1 mole we are getting 2 mole of O2. 2 mole of O2. Okay. So we have to find out the charge of n mole of electrons, right? We have to calculate the charge of n mole of electrons. N mole of electrons, then how we can calculate the charge of n mole of electrons? By the formula Q is equals to Nf. Okay, F is the Faraday here and N is the number of electrons that is involved and Q is the charge. So in this case, what will be Q? Q will be number of electrons involved here is 2 and F will be as it is. Okay, so for H2O, 2 Faradays of 2 Faradays required. Okay, so for 1 mole of H2O to O2, 2 Faradays required. So option A will be of option 2. Okay. Next is B. 1 mole of MnO4 to Mn plus 2. So MnO4 minus 2 Mn plus 2. So how much electrons are involved in this reaction? Okay. So 5 electrons are involved in this reaction. You can balance the equation. 5 electrons are involved in this reaction. So how much charge will be there? The charge will be calculated by Nf. Okay. So N here is 5 electrons because 5 electrons are involved and it is F. So for Mn1, which will be the number of Faradays required? There will be 5F, which means option number 4. Okay, I am writing it here. For A it is option 2. For B it is option 4. Okay, let's find out for C. For C, 1.5 mole of Ca from molten CaCl2. 1.5 mole of Ca from molten CaCl2. So 1.5 mole of Ca, what will be the reaction here? So Ca plus 2 electrons will give us Ca. Okay, will give us Ca. So 1 mole of Ca will give how much? Faradays. Q is equals to Nf now. So 2 electrons are involved. So 2 Faraday will be given. And it is asking for 1.5 mole of Ca. So for 1.5 mole of Ca, what will be there? 2 into 1.5, that is 3 Faradays. Right? So option number C. For option number C, 1.5 mole of Ca from molten CaCl2, it will be option 1. Which means that C will be having option 1. Next is 1 mole of FeO to Fe2O3. So 1 mole of FeO to Fe2O3. So let us write the equation first. Fe plus 2. FeO will have the plus 2 oxidation state in this Fe. Then it is converted into Fe plus 3. Okay. So 1 mole of Fe, 1 mole of Fe will require 1 Faraday of electricity. Right. 1 Faraday of electricity because 1 electron is involved in this case. Now, so Q here will be NF, which is 1F. 1 electron is involved, so Q will be NF. So for option number D, what will be the correct answer? For D, it is 3. Right? So in this, which is the correct option, we will find out. Option number 3. A is 2, A is 2, B is 4, B is 4, C is 1 and D is 3. Okay, option number 3 will be the correct answer in this case. Right? Let us see for question number 52. Which reaction is not a redox reaction? Which reaction is not a redox reaction? We have to find out. Okay. So for a redox reaction, this is clearly a question from redox reaction chapters. Okay, and its subtopic is oxidation number. So in explanation, we can say that what is a redox reaction? We have to find out now which is not a redox reaction. Highlight the not word. A redox reaction is any chemical reaction in which the oxidation number of a molecule, atom or ion changes by gaining or losing an electron. Okay, which means that the oxidation state should change. Then only it can be a redox reaction. So let us see in which of these following equation the oxidation number is not changed. Okay, which is not changed, then only it will be not a redox reaction, right? So see in this case, H2 plus Cl2 will give 2HCl. So H will be having an oxidation number of 0, Cl2 will be having an oxidation number of 0. Why this is so? Because it is in elemental state. Okay, it is in elemental state, so elements will have an oxidation number of 0. And when HCl is calculated, then the oxidation state of H will become plus 2 and oxidation state of Cl will become minus 2. So clearly the oxidation number is changed in this case. So it is a redox reaction. Okay, it is a redox reaction. Then for second equation, BaCl2 plus Na2SO4 will give BaSO4 plus 2NaCl. Okay, so here Ba oxidation state is plus 2, Cl oxidation state is minus 2, Na2 oxidation state is plus 1 and S oxidation state is plus 6 and O oxidation state is minus 2. We can also calculate for SO4 also. Okay, SO4 will have SO4 also we can calculate. So here B oxidation state will be plus 2 and Cl it will be minus 1, Na will have plus 1 only and SO4 will have, for S it is plus 6 and O it is minus 2. So here in this case the oxidation number of chlorine is changed, right? So chlorine is changed, then it is also a redox reaction. Then on looking upon the third one, for Zn will have an oxidation number of 0, Cu will have an oxidation number of plus 2, SO4 will have a minus 2. Okay, so Zn is changed to plus 2, Cu is changed to 0. It is clearly a redox reaction. Option number 4, 2KCl3 plus I2 will give 2KiO3 plus Cl2. So here see, the oxidation okay, so the oxidation state of K will be plus 5, here it is also plus 5, Cl will be minus 1 and here Cl will be 0. Okay, it is also redox reaction. Okay, sorry, I have there is one confusion here. Okay, so option 2 will be the correct answer in this case, because Ba will be plus 2, here Ba is also plus 2, Cl is minus 2 and here Cl will be minus 2 only. Okay, Cl here it is written minus 1 because it is considering only one Cl, but here see 2 Cl is given. So you can also make mistakes like this. Okay, so we don't have to forget this 2. So on considering this 2, it will become minus 2 as well. So in this case all the oxidation state are unchanged. Okay, so it is not a redox reaction. So option number 2 will be the correct option here. Okay, now let's move on to the next question, question number 53. Question number 53 says that intermolecular hydrogen bonding is present in. So we have to find the intermolecular hydrogen bonding only. So intermolecular hydrogen bonding, it is from basic principles of organic chemistry, the first chapter of organic chemistry, right? And its subtopic is hydrogen bonding. So let us see. Option number 1 will not form intermolecular hydrogen bonding. HF will also not form. Option number 3, yes, option number 3 will form the intermolecular hydrogen bonding. How? We can see here. Okay, this is the benzene ring, and here it is NO2. This group is NO2 and this is OH. Okay, and these are linked in such a way that the oxygen and hydrogen are forming an intramolecular hydrogen bonding. Okay, so oxygen and hydrogen are connected by intramolecular hydrogen bonding here. So option number 3 will be the correct option. Okay, next is question number 54. Okay, so all these are not so difficult. Difficulty level is not so much difficult. It is not at so hard. Okay, if we consider the difficulty level once, then for 51 the difficulty level is moderate. Okay, it is moderate. If you know the formula of Q is equals to NF, then it is easy for you. But to remember this conversion, if you know this formula, it is very easy for you, and if you don't know, then it is moderate for you. Okay, I am going towards the average student's mentality. Question number 52. In question number 52 also, it is a moderate level question. We have to find out the oxidation state only, and if we know the oxidation state of every element, then it is easy for us. In question number 53 also, it is so easy type question. It is very easy because we have to find out the hydrogen bonding only, right? And next, move on to the next question. Question number 54. Felling solution of A is, okay, felling solution A is, felling solution A is aqueous copper solution, copper sulfate solution, right? Aqueous copper sulfate solution is the correct option. So aqueous copper sulfate solution, option number 3, it is the correct option, right? Okay, felling solution is composed of two types of solution now, A and B, felling solution A and felling solution B. Felling solution A is of aqueous copper sulfate solution and felling solution B is sodium potassium tartrate, right? Tartrate, or it is also called Rochelle salt, right? Sodium potassium tartrate plus sodium hydroxide. Okay, so option number 3 is correct for question number 54. For question number 55, 1 gram of sodium hydroxide was treated with 25 ml of 0.5 molar HCl solution. The mass of the sodium hydroxide left unreacted. Okay, don't forget this line. It is asked that what is unreacted. Okay, so let us see this. It is from basic concepts of chemistry, and it is the subtopic is mole concept. So let's find out the answer. So the volume of solution is given as 25 ml. It is given in the question, and 25 ml we will convert it into liter, then it is 0.025 liter. For molarity of HCl is also given 0.5 molar. So we have to find out the number of moles of HCl first. Okay, for calculating the number of moles of HCl, what is the formula? Molarity into volume. So we will get it as number of moles of HCl is 0.01875 mole. Okay, now since the reaction between sodium hydroxide and HCl, okay, so the reaction, if we consider the reaction of NaOH and HCl, then it happens in 1:1 ratio. Okay, so for 1:1 ratio, if we consider, we have find out the number of moles of HCl. So if number of moles of HCl is 0.01875 and both are equal in ratio, then the number of moles of NaOH will also be 0.0185, right? You are getting it now? Yeah. So it is asked the mass of sodium hydroxide which is left unreacted. So now we have calculated, we have found out the number of moles of NaOH also. So we will calculate it by subtracting it from the total number of moles. Okay. The molar mass of NaOH is approximately 40 gram per mole. This we know, that molar mass of NaOH we know. And initial mass is 1 gram. So mass of NaOH remaining will be what? Initial mass minus the mass reacted. Okay, we have to find out the remaining mass of NaOH, right? So it is initial mass minus the mass reacted. So mass reacted will be number of moles of NaOH into molar mass of NaOH, and mass reacted will be 0.75. Okay, so this we have calculated the mass reacted, and mass of NaOH remaining. How much is remaining? 1 gram minus 0.75 gram, right? It comes out to be 0.25 gram. So option number 4. 0.25 gram and converted into milligram, what it will come? It will come 250 milligram. Okay, option number 4 will be the correct answer here. Okay, so what do you think? What is its difficulty level? It is difficulty level, it comes out to be 3. It is not, okay, it is 3. I have given this as a lenient question because if you know the formula, if you are putting it correctly, the equation, the molarity formula, so it is easy for you. Otherwise, you can consider it as a difficulty or moderate level only. Okay, you can consider it as moderate only, or it will be difficult for some people who are running away from physical chemistry, right? Okay, so question number 56. Match list 1 with list 2. Okay, so for NH3, we have to find out what we have to simply find out the shape or geometry of the compound. Okay, for shape and geometry of the compound for NH3, NH3, what is the geometry of NH3? This is the structure of NH3, yeah, and it comes out to be trigonal pyramidal. Why it is trigonal pyramidal? It looks like a tetrahedral shape, right? It looks like a tetrahedral shape, but it is trigonal pyramidal because of the presence of lone pair of electrons. Okay, because of the presence of lone pair of electrons, it comes out to be trigonal pyramidal. So option A will be trigonal pyramidal, right? A, sorry, yeah. For A it is 1. I am writing here. For A it is 1. Okay. Next is for BRF5. For BRF5, this is the structure BRF5, and its you can say geometry. It is square pyramidal. It is square pyramidal because of the presence of lone pair of electrons. You can see here, na, one lone pair of electron is present. Therefore, its geometry is square pyramidal. So BRF5 will have square pyramidal geometry. Okay. Option B ka 4. Option B ka 4. Next is XCF4. For XCF4, this will have the square planar geometry because there are two lone pairs present. This and this, there are lone pair, no? Two lone pair present. So option C will have square planar. Okay, C ka 2. SF6 will have trigonal pyramidal. Okay, SF6 will have trigonal pyramidal. SF6 geometry. SF6 is drawn like this. Okay, geometry is like this, and it follows the octahedral geometry. Okay, so D ka 3, right? Question option D ka 3. So which is the correct option among all this? Option number 3. Option number 3. A ka 1, B ka 4, C ka 2, and D ka 3. Okay, this is the correct option. Next is and difficulty level you can consider, it is simply asked from the geometry. So it is easy for you, it is very easy. It is an easy question. Question number 57. Okay. Question number 57 says the E naught value for Mn plus 3 to Mn plus 2 couple is more positive than that of Cr plus 3, Cr plus 2 or Fe plus 3, Fe plus 2 due to the change of. Okay, so we have to find out that the E naught value for the changes of Mn plus 3 to Mn plus 2. Okay, so here see, it is from DNF block elements, right? And it is the properties of DNF block. It is from properties of DNF block. So here see explanation, the higher E naught value for Mn plus 3 to Mn plus 2, higher E naught value is observed because Mn plus 3 has outer electronic configuration of 3d4. Okay, we know that Mn plus 3 will have the 3d4 electronic configuration, and Mn plus 2 will have an electronic configuration of 3d5. Okay, so what is the E naught value? The configuration jumps from 3D4 na 3D4 to 3D5, which means that D4 to D5 it will jump. So D4 to D5 it will jump, so it will give a positive change. Okay, it is more positive, will give a positive value. So option number 1, 57, option number 1 is the correct answer. Okay. Next is question number 58. Question number 58. Match the list 1 with list 2. Okay, list 1. List 1 says that the different thermodynamic process is given and we have to find out the conditions, under which conditions these are fulfilled. So for isothermal process we know that the temperature remains constant. Okay, the temperature remains constant, which means that option A will have temperature remains constant. Option A will have option 2 as the correct answer. Okay, so for A, let us see option 2. Okay, in second option only option 2 is given. So this is the correct answer only. Let us see all other options as well. So for isochoric process, it will have volume constant. Okay, the volume will be constant. So isochoric process, the volume will be constant here. Next is the isobaric process. Okay, let us see B ka 3. B ka 3 is also here. Okay. Next is isobaric process. Isobaric process. Next is isobaric process. Isobaric process, the pressure remains constant. Okay, isobaric pressure will have the constant pressure, isobaric process. Next is adiabatic process. Adiabatic process, there is no heat exchange. Okay, so option number 2 is the correct option. Right? So it is a very easy question. It is directly from NCERT lines. It is a very easy question. Okay. Next is question number 59. The activation energy of any chemical reaction can be calculated if one knows the value of. If one knows the value of, this question comes from chemical kinetics, okay, and it is from Arrhenius equation. Activation energy, it is from Arrhenius equation. So activation energy, what is activation energy? It is the amount of extra energy which is required by the reacting molecule to get converted into product, and it is described as the minimum amount of energy which is needed to activate or energize molecules or atoms so that they undergo chemical reaction or transformation. Okay, so activation energy is simply the extra amount of energy that is required from an electron to jump to higher levels, right? So the formula used for the calculation of activation energy EA. What is the formula which we are using to calculate the activation energy? It is K is equals to AE. K is equals to AE EA by RT. Okay, where K is the rate constant, A is the Arrhenius constant, EA is the activation energy, R is the gas constant. Okay, so by this we can calculate, and we have to, what we have to do, we have to formulate this reaction. We have to simplify, or you can say we have to calculate this reaction in such a way that we can come to a conclusion. Okay, so what we will do, we will take log on both sides. So on taking log on both sides, ln k will become ln a minus ea by rt ln e. Okay, so so now we are removing the ln with 2.303. Okay, so it will become log k, then 2.303 log a minus ea by rt. So log k will become log a minus ea by 2.303 rt. Okay. Now, activation energy of a chemical reaction can be determined by evaluating rate constant at the two temperature. Okay, when we will summarize this this equation, what we will get? We will get log k minus log k2 minus log k1 equals to Ea by 2.303 R 1 by T1 minus 1 by T2. Okay, and log k2 by k1 comes out to be Ea by 2.303 R T2 into T1 by T1 into T2. So it is clearly when we know the value of K2 by K1, we can easily calculate the activation energy, right? So what is K2 by K1? It is the rate constant. K2 by K1 is the rate constant here. Okay, so option number, which option is correct? Option number 2, rate constant at two different temperatures. If we know the rate constant, then the activation energy can be calculated, right? Okay, so it is difficulty level 1. It is easy to moderate type question. Okay, easy to moderate type question. You just have to equate the equation. Next is question number 60. A compound with molecular formula of C6H14 has two tertiary carbons. Its IUPAC name is, okay, a compound with a molecular formula C6H14. Its molecular formula is given and it has two tertiary carbons. So it is from hydrocarbons chapter and its IUPAC nomenclature. Its subtopic is IUPAC nomenclature. Okay. So for explanation, a primary carbon is attached to only one other carbon. Secondary, okay, we know what is primary carbon, what is secondary carbon, what is tertiary carbon. Okay, and C4H14, C6H14, it is a saturated alkane because its general formula comes out to be CnH2n plus 1. Okay, it is a general formula of alkane, right? It is the general formula of alkane. So it has two tertiary carbons. So two tertiary carbons might be this type of structure is drawn. So it is tertiary carbon, it is tertiary carbon, and it is primary carbon, it is primary carbon, primary and primary carbon. Okay. So the compound, what is the compound? What is the name of this compound? What is the name of compound? It is okay, let's do the nomenclature. 1, 2, 3, 4. Okay. So at second and third position, the methyl group is attached to 2,3 dimethyl, and for 4 carbons it is butane. Okay. Option number 1, 2,3 dimethyl butane. Okay. Option number 1. Yeah. So option number 1 and difficulty level is easy. It is easy type question. Right. Question number 61. Spin only magnetic movement is same for which of the following ions? Spin only magnetic movement. So what we will do for spin only magnetic movement? This topic is from D and F block elements and it is subtopic is magnetic properties. Okay. So for spin only magnetic movement we will follow this equation. We will follow this formula, root under n plus 2. Okay. And n is the number of unpaired electrons, right? So let us calculate for all of these. For Ti, number of unpaired electrons is 3d1 its electronic configuration and one it has 1 unpaired electrons. For Cr plus 2, 4 unpaired electrons are there. For Mn plus 2, 5 unpaired electrons are there. For Fe plus 2, 4 unpaired electrons are there. For Sc plus 3, 0 unpaired electrons are there. Okay. So spin only magnetic movement is same. It is asking that which of these will have spin magnetic movement same. What it means? It means that which of the following will have same number of unpaired electrons. Okay, same number of unpaired electrons are for chromium plus 2 and for Fe plus 2. Okay, for chromium and for Fe plus 2. So option number B and D. Option number B and D is option number 3. So option number 3 is correct for question number 61. Okay. Next is for question number 62. For question number 62, arrange the following elements in increasing order of their electronegativity. So increasing order of electronegativity is asked. It is from classification of elements and periodicity in properties. Okay. And its subtopic is electronegativity. So electronegativity, what is electronegativity? It is the measure of an atom's ability to attract the shared pair of electrons to itself. Okay. On the periodic table, the electronegativity generally increases as we move from left to right. Okay, so let us assume that this is the periodic table. On moving from left to right, this is left, this is right. What happens? That the electronegativity, what happens? It increases. Okay, electronegativity increases on moving from left to right. So among all this, which is the most electronegative element? We know that fluorine is the most electronegative element in the entire periodic table. Okay, so fluorine will have the most electronegative element. So automatically option 1 and 2 is incorrect. Let us see for other compounds. Okay, so this one we will calculate. This one is clear, na? Because as we move from left to right, the electronegativity increases. So fluorine, then oxygen, then nitrogen and oxygen. Carbon. In a group, electronegativity decreases as the size increases. Okay, as the size increases, As we move, we can say that as we move down the group, the electronegativity increases as well, which leads to the ability to attract the electron decreases. Okay. Okay, sorry. Size increases and electronegativity decreases. As we move down the group, the electronegativity decreases. Okay. So here silicon which is below, okay, so it will have the least electronegativity. So option number 4, this will be the correct order. Sorry, option number 4, not option number 3. Yeah, option number 3 will be the correct order. Okay, silicon, then carbon, then nitrogen, then oxygen, then fluorine. Okay, option number 3. Yeah. Next is question number 63. So it is a difficulty level, it is a moderate type question. Okay, it is a moderate. Question number 63. Which one of the following alcohols react instantaneously with Lucas reagent? Okay, so we know that in Lucas reagent, 3-degree alcohols are reacted immediately. It is from alcohol phenols chapters, okay, and it is from identification of alcohol. Yeah. So Lucas test, it is used to distinguish between primary, secondary and tertiary alcohols. We know that, and it will give immediately, it will give precipitate with 3-degree alcohol. So among all this, which one is the tertiary alcohol? Second option is the tertiary alcohol. So second option is the correct option, right? Next is question number 64. Okay, so that question was an easy question. Question number 64 says that given below are two statements, statement 1 and statement 2. So let's read statement 1 first. Both CONH3 whole 6 plus 3 and COF6 whole minus 3 complexes are octahedral but differ in their magnetic behavior. Okay, so let's see this. Okay, so statement 2 says that CONH3 whole 6 is diamagnetic whereas COF6 is paramagnetic. Okay, so one is saying that they have the same magnetic behavior and the second statement is saying they have the different magnetic behavior. Okay, so let's find out for both. So this is the question from coordination compound and its subtopic is valence bond theory. So both these are octahedral complexes. F minus is anionic ligand and I minus charge. Sorry, and having minus 1 charge. F is having minus 1 charge. So CO has plus 3 oxidation state and CO's electronic configuration is 3d7 4s2. Now for CO plus 3. CO plus 3, it will have 1, 2, 3, 4, 5, 6, 6 electrons, okay, and 1, 2, 3, 4. 4 are unpaired. 4 of them are unpaired. Now, if fluorine is a weak ligand and pairing of electron donor occurs, so COF6 3 minus is paramagnetic in nature, right? It is paramagnetic because it has 4 unpaired electrons. Now, if we consider COCN whole 6, so CN is an anionic ligand and have minus 1 charge, so CO is in plus 3 oxidation state and also it has 4 unpaired electrons. Now, as CN is a strong field ligand, so CN here is a strong field ligand and fluorine is a weak field ligand. So what will CN do? CN will cause the pairing of electrons. So upon pairing, what happens that there will be 0 unpaired electrons. So it will become diamagnetic in nature, right? It will become diamagnetic in nature. So option number yeah. So correct option is option 3. Option 3 is the correct option. Statement 1 and both statement 1 and statement 2 is true, right? Question number 65. Given below are two statements. Statement 1 says the boiling point of hydrides of group 16 elements follow the order. The boiling point of hydrides of group 16 elements follow the order H2O, then H2TE, then H2SE, then H2S. Okay, this is also a statement type question. Statement 2 says on the basis of molecular mass, H2 is expected to have a lower boiling point than the other members of the group, but due to the presence of extensive hydrogen bonding, it has higher boiling point. In the light of the above statement, choose the correct answer from the options given below. Option number 3. Option number 3 is the correct option. Okay. Uh, so it is from classification of elements chapter. Okay. Gradual increase in boiling points down the group happen as the relative molecular mass of the molecules increase. Gradual increase in boiling points down the group happens as the relative molecular mass of the molecules increases. Also, what happens, the boiling point of water is anonymously high because of extensive hydrogen bonding. Intermolecular hydrogen bonding is responsible for the high boiling point of water. Okay, so boiling point of hydrides of group 16 elements. So this is the order. So H2O, then H2S, then H2Se, H2Te. Okay, it's this is directly proportional to its molecular weight. So boiling point will have the order of H2S, then H2Se, then H2Te, then H2O. Okay, so this is the correct option. This is the correct boiling point order that is given, and its statement. Its statement is also true. Its statement or statement 2 is also true. The reason for this statement 1 is also true. Okay. So it is because of molecular mass, and H2 is expected to have a lower boiling point than other members due to the extensive hydrogen bonding, right? Question number 66. Let's move on to question number 66. In question number 66, the matching is given. We have to match. Okay. ML. What is ML here? It is from atomic structure. Okay. We are asked the quantum numbers. Quantum numbers, it is from atomic structure chapter. So it is from atomic structure chapter ML. ML here is the orientation of orbital. It is the orientation of orbital. So A is option number 3. For A, option number 3 is correct. Option number 3 is correct. So option 2 and option 3, it will be incorrect. For MS, option number 4. For MS, orientation of space of electron. Okay, orientation of spin of electron. So for option B, option 4 is the correct one. Option B, option 4 is the correct one. It is also correct. For L is the shape of orbital. L is the shape of orbital. So for L, option number 1 is correct. Okay, option number 4 is the correct option in this case. So it is the easy question if you know what does this quantum number means. It is directly asked that what does they provide, what information do they provide. So it is easy one. Next is question number 67. Okay. So for question number 67, match list 1 with list 2. So this is the reaction, and which reagent is involved in this reaction, we have to find out. So this is from organic compounds containing oxygen chapter, and it is properties of aldehydes and ketone. Okay. See. So for converting from this to this, what is the reagent involved? It is O3. Okay. O3 is required. It is used for the reduction to ketone. It is used in the reduction reaction. Okay. These both are used in the reduction reaction. So option A will be O3 and ZnH2O. A ka 4 which is correct. Okay, A ka 2 is wrong, A ka 3 is wrong. So option from among option 1 and option 3 we have to find out. From B, this anhydrous AlCl3 and this compound. This is true. So anhydrous AlCl3, this is the Friedel-Crafts reaction, I think, right? Option number B ka 1. Option B ka 1. B ka 1 is true in both the cases. Then option number C. Option number C is CrO3. So CrO3, this is what type of reaction is this? This is Jones oxidation reaction. Jones oxidation reaction, right? So Jones oxidation reaction, option number C ka 2. Option C ka 2. C ka 2 is also correct. Okay. Sorry. Option number, yeah, Sika 2. So, Sika 2 and then Dika 3. Dika 3 is also correct. So, option number 1 is the correct option. Question number 68. Question number 68. Identify the correct reagents that would bring about the following transformation. Here we will also, okay, so are you seeing the pattern? Are you seeing the pattern? You are not being asked what is the product for this reaction. You have been asked the reagents. You are given with the products and you are asked with the reagents. So just try to, if you are doing something, now just try to think every other possible way that the question can come. Okay, like in this case they have asked the reagents. What are the reagents that are used? Okay, so we are always trying to solve the products. We are trying to find out the products, but this is not the case. You have to consider in mind the reagents also. Okay, so in this case, this is the reactant and this is the product. What is the reagent involved in this reaction? Option number 4, organic compounds containing oxygen. This is also from organic compounds containing oxygen. It is the organic compounds containing oxygen is a big chapter. Okay, it comprises of organic compounds containing oxygen comprises of alcohol, phenols and ethers as well as aldehyde, ketones and carboxylic acid. Right. So it is a very big chapter and a lot of questions have been come from here. So, what is the correct answer? This BH3, H2O2OH and PCC. Okay, so like this. This then on adding BH3, this we will get, then adding H2O2, this reaction we will get, and then adding PCC, this reaction we will get. Okay, this is the mainly this is oxidation, hydroboration, oxidation reaction, hydroboration, oxidation reaction. Okay, hydroboration, oxidation reaction we must have read. It is a famous name reaction. So in this way we will solve this question. Next is question number 69. For question number 69, the reagent with which glucose does not react to give corresponding test products are the reagents with which glucose does not react. Okay, so glucose does not react with CIFS reagent NaHSO3 and 2-DNP. So CIFS reagents is given, CIFS reagents is there and NaHSO3 is given. So option B and D, option B and E. Option number 1. 1 is the correct option here. Okay. For question number 70, match list 1 with list 2. So this is list 1, ethane, carbon molecule. We have to find out the number and types of bonds between the two carbon atoms. We have to find out the type of bond between the two carbon atoms. Okay, not the overall bond, only two carbon atoms we have to find out. So for ethane is this, we will get the structure as this ethane. Okay. So ethane will have this carbon-carbon bond we have to calculate. So there is 1 sigma bond between this carbon-carbon bond and 0 pi bond. Okay. 0 pi bond. For ethene carbon-carbon bond will have 1 pi bond. For carbon molecule C2 molecule, it is 1 pi bond. And for ethyne, it will have 1 pi bond and 2 sigma bond. Okay. So for option A, 3, third one is correct, 1 sigma bond. Ethene, for ethene, option number 4, 1 sigma bond and 1 pi bond. Okay, yeah, 1 sigma bond is also there. Okay, 1 sigma bond and 1 pi bond. So for ethene, for D, for C, ethyne, wait. For C, carbon molecule. For carbon molecule, option 2. For carbon molecule, option 2. Okay, 2 sigma bond, 2 pi bonds. Yeah, 2 pi bonds are there. 2 pi bonds are there. And for ethyne, mm, 1 pi bond and 2 sigma bonds are there. 1 pi bond and 2 sigma bonds. Okay, I think 1 pi bond and 2 sigma bonds should be there, right? Okay, so option number 1 will be the correct option here. This question, I think it is printed wrong. Okay, 1 pi bond and 2 sigma bond, because it is not possible that any compound will have 1 sigma bond and 2 pi bond. If it is having 2 pi bond, then it will obviously it will have 1 sigma bond, 2 sigma bonds as well, right? So this one is, I think it is incorrect question. It is printed. For question number 71, among group 16 elements, which one does not show -2 oxidation state? Which one does not show -2 oxidation state? So it is from p block elements and it is from group 16 elements. So explanation, in the group 16, most metallic element, that is most electropositive element, does not show -2 oxidation state as its electronegativity is very low. Hence polonium does not show -2 oxidation state. So polonium does not show -2 oxidation state because it is the most electropositive element. Okay. Option number 2 will be the correct option, and if you know the D block correctly, it will be easy for you. It will be the easy question for you. Question number 72. For a reaction 2A tends to B plus C, Kc is given as 4 into 10 to the power minus 3. At a given time, the composition of reaction mixture is A is equals to B is equals to C equals to composition is given. So for the given reaction, Qc is given by B, concentration of B into concentration of C, concentration of B into concentration of C by concentration of A square. Okay, by this reaction, we will find out this type of equation. So when we know that A is equals to B is equals to C, then Qc equals to B is also 2 into 10 to the power 3, C is also 2 into 10 to the power 3, and A square is 2 into 10 to the power minus 3 whole 2. So it comes out, overall comes out to be 1. So Qc will be greater than Kc, so reaction will be proceed in backward direction. Okay, so reaction will proceed in backward direction. Option number 1 is correct. For question number 73, which plot of ln k versus 1 by t is consistent with Arrhenius equation? So according to Arrhenius equation, this is the Arrhenius equation question and it is from chemical kinetics. Okay, according to Arrhenius equation, k is equals to Ae minus Ea by RT. So ln k, we will put ln at both sides and ln k is equals to ln A minus Ea by RT. Okay, so this is the slope, ln A is the slope. So by this we will find out that it will be a backward direction, or you can say it will be a negative plot. It will be the negative graph. Option number 2 is the correct option in this case, right? In question number 74, its difficulty level is easy. Okay, it is an easy type question. You have to just find out that if the slope is negative, then the graph will always be negatively deviated. Okay. Question number 74. In which of the following equilibria Kp and Kc are not equal? Kp and Kc are not equal. So it is from equilibria and Kp and Kc relation it is asked. So we know that Kp is equals to Kc RT by RT whole delta n. If delta n is 0, then what happens that Kp equals to Kc and delta n is the number of moles of product minus number of moles of reactants. So in option 1, 2 and 4, the value of delta n is 0, hence Kp is equals to Kc. Okay, so it is asked that which is not equal. So PCl5 gives PCl3 plus Cl2. In this case, what happens that PCl3 plus Cl2. So there is two products and there is one reactant. So delta N in this case equals to 1. Okay, it is not equals to 0. So it is Kp and Kc here, it is not equal. So option number 3. Option number 3 will be the correct option. Next is question number 75. Given below are two statements. Statement 1 says the boiling point of three isomeric pentanes follows the order N-pentane greater than isopentane greater than neopentane. Statement 2 says that when branching increases, the molecule attains the shape of a sphere. This results in smaller surface area of contact, due to which the intermolecular forces between the spherical molecules are weak, thereby lowering the boiling point. In the light of the above statement, choose the most appropriate answer from the questions given below. Okay, so in this case, this question is from general organic chemistry and it's from physical properties. Okay, so boiling point of three isomeric pentanes is given. Now, the branch change isomer of an alkane has a lower surface area than that of straight chain isomer. So, branch change isomer has a lower boiling point than its straight chain isomer. Okay, this we know that if branching of alkane, this type of question I think I remember that we have in the PYQs also. Okay, in the PYQs also this type of question is there. In a branch change isomer of an alkane has low surface area, then its straight chain of isomer So the branch chain isomer of an alkane has a lower boiling point than its chain isomer. Also, branching of alkane makes the molecular compact and brings various atoms closer, which result in the decreasing of molecular size. Okay, we know that since a sphere has minimum surface area, therefore van der Waals forces of attraction are minimum, and hence the boiling point of alkane decreases with branching. Okay, decreases with branching. So when branching increases, the molecules attains the shape of the sphere due to the intermolecular forces of attraction between the. Okay, so this statement is also correct, and the reason is also correct. Okay, option number 3 is also is the correct option for this option, this question. Okay.